This is the part 2 of classes and objects. This is more in-depth now. So this is the approach of working with classes. First of all, you need to write the class, or you can reuse one that's already created for you. Usually Apple has already plenty of classes very nicely done that you can reuse. Okay? Now, what you need to do is, once you have the class written down, you create objects, or just one object or multiple objects out of it. It's called instantiating, okay, or instantiate this class. Once you have these objects, you access the object properties and methods, okay? So earlier I showed you the position, I showed you the address. These were properties, and actions such as get the location or ship to the address. All these are methods. Okay, and once you're done manipulating these objects, what you gotta do is clean up after you're done. And by cleaning up, we mean disposing of the objects. So once you're done with it, you need to tell the program that you don't need them anymore, and you would remove them from memory so that other items or other programs can reuse that memory. Now, something that I have not written here, but usually before cleaning up, you might want to store them. So there may be data storage. We don't have to do it all the time, but nowadays you usually want to persist the data. So you want to save it somewhere so that you can reuse it later. Okay, so principles of object-oriented programming are OOP for object-oriented programming. Now, these are usually interview questions, so it makes me a little bit smile when I see this. So know that if someday you wanna go, you're gonna have an interview, they might ask you what are the principles of object-oriented programming, and it's a pie. So to memorize it, you have to remember as a pie. Okay. So A stands for abstraction, P stands for polymorphism, I for inheritance, and E for encapsulation. Let's take a look at each of them in details. So, abstraction. Think about the big picture of a class. Do not worry about the details yet, okay? So just look at it from like a bird's view. Think of the class potential properties and methods, okay? You should do some kind of a brainstorm and say, okay, this could be the attributes or the properties and the actions or the methods of this class. Now, you don't have to use them all, and you may have to remove some of them later, but at least start writing them down. Do not focus on its implementation logic or details yet. Okay, so this is only later on. Right now, you just abstract and see what belongs to the class and what does not belong to the class. And here is a concrete example here. You have a class named book, and some of the properties of that book that belong to the book are title, the author name, or the pages, okay? And some of the methods you can use on that are get title, get author name, and get page count. All right, the next principle of object-oriented programming is polymorphism. Now, what do we mean about polymorphism? Okay, so one type of class can be used like another type of class, and it will just work. And I know it's kind of weird to understand, so this is a concrete example here. The first class, let's say it's a triangle, and one of the actions you can perform the triangle is to get the area. Now, you can polymorph this into a square, and the action get area will also just work there, okay? All right. Now, another principle is inheritance. What's inheritance? A class can be created from a previously created class, and the new class inherits all the properties and behaviors of the parent class, okay? So here is a concrete example here. You have the parent class here that's named animal, okay? So animal is the parent class. It's got one property called weight, okay? And it has a function called getWeight. This is the action, okay? Now you have the class that's inheriting, which is the pet, okay? Class pet. And how do we know it's inheriting? It has the column and animal, okay? So it's getting all the stuff from the class named animal. Var name string. So pet has everything that the animal has, plus some extra ones. And the extra ones are right below the name and display information, okay? Display info, which is NSLog. It displays the name and the weight. Now, if you see in the NSLog, you see that the weight does not come from the pet, it comes from the animal, okay? So you can use within the pet any properties or action that were within the animal. So note, the parent class is also called the base class, the superclass, or the ancestor, okay? So remember this, some people come from different programming background and they might use different terms, okay? All right. Now, the last principle of object-oriented programming is encapsulation. Last but not least, so what's the encapsulation? A class behaves like a black box, where the inner parts are encapsulated within a container. What do we mean by that? It means that we are not interested in how the components are working within. What we really are interested in, or mostly interested in, is how to interact with the class by using its methods. Okay, so let's look at a concrete example here. Let's look at the smartphones. Okay, so let's say you have a class called smartphone. One object would be the iPhone, or the BlackBerry, or any other Android phone, such as the Nexus one, okay? So all of these phones are smartphones, and those are objects because they're instantiated. Now, we want to be able to make phone calls and use different apps, right? But we are really not interested in how the hardware, capacitors, and circuits boards handle electric currents, right? So as you can see, behind the scenes, there's plenty of things happening, you know. The CPU has a clock, is reading millions of instructions per second, but we don't really care. What matters is that we can interact with the phone, make phone calls, and use different apps, right? All right. Now, here is how you instantiate objects in Swift. So first, on the left side, I want you to see that we have a class called animal, a class called pet that inherits from everything that the animal has, and then a class called dog that's inherits from pet. So the dog inherits from pet, and the pet inherits from animal. So the dog has a double indirect inheritance, okay? So the dog has anything that the pet and the animal uses. Now, let's look on the right column. We do let Roscoe is equal to dog and let Lassie is equal to dog. So what are we doing here? We are instantiating objects. We have two real objects now. We have Roscoe and Lassie, and these two are of class dog, okay? So this is the type that they have. They are dogs. And then we can work and access their properties or define their properties. We do Roscoe.weight is equal to 10, Lassie.weight is equal to 15, and we change the breed. Roscoe's breed is Chow Chow, Lassie.breed is Terrier, and then we change the name. Roscoe.name is Roscoe, and Lassie.name is Lassie. And then, finally, what we do is Lassie.displayInfo. We are calling the action or the method from the pet, okay, the displayInfo. And as you can see below, this is what you see in the console. Lassie weighs 15 pounds, and Roscoe weighs 10 pounds. All right, I would advise you guys now to go and get some exercise cranking to get to understand this deeper, because this is really the foundation of object-oriented programming. Whether you're using Swift, Objective-C, C#, or Java, you really need to understand really well. Thanks for watching.